Hey, how's it going? It's Chris here from LunaSec. I wanted to give you a quick spin around LunaTrace and how it actually works under the hood, because I think it's pretty interesting. So let's take a look at one of our projects here. So I'm going to open up Project Gutenberg. Looks like we've already scanned it, and you'll notice that it takes LunaTrace, a couple seconds to actually load this page. So my question is, what's actually going on underneath the hood? So, right, we have information about packages, we have information about vulnerabilities, we have recommended fixes, we have transitive dependency analysis, right? Where we're actually scanning to see if you can go from one dependency all the way to another in a call chain. So all that information is being collected or has been collected, but now we need to show the user. So the way that we're doing this, I personally find pretty interesting. And it all starts with the database model resolved manifest. So resolved manifest is a package lock. It is the resolved dependencies based off their version constraints as they appear in the package JSON. So if we take our build here, take our build identifier, go into our database and we search for that build ID, we can see that there's one result. So right, that's the page that we're loading. That's the data from the database. So we can take a look at all the dependencies that exist in the database. So we might notice that this is a flat list, right? A dependency graph is something that's a graph, right? It's something that's connected. There's dependencies, there's resolved versions, and they're all sort of mixed around in this web of crazy dependency hell. So it's flat in the database. How do we actually get it to be modeled as a graph? So we've done and put together, or we've coded an SQL function called child edges recursive, or I guess it's technically resolved manifest child edges recursive. And what this function does is it takes that flat data set and it will start at one point, right, the root node of our dependencies, right, our root of our manifest, and it will crawl all those dependencies so that we make sure that we're looking at each and every one, as well as building all those connections along the way. So what this allows us to do is something really powerful. So we can traverse all this data, and as we're traversing it, we can tack on any other data that we want, right? For example, a package might have a set of vulnerabilities. So as we're traversing our package manifest in our database, we can just say, oh yeah, while you're at it, toss on some of those vulnerabilities. I'm going to need that in the front end. So let's take a look at how we can do that with GraphQL. So I'm going to search for a resolved manifest by primary key. And we're going to go back here and get our resolved manifest. And what I'm going to do is I'm going to ask for the recursive child edges. And let's just see what happens if we get the ID. So this is just returning all the IDs of those edges. So what I can do is I can drill down further, a child package, and we can see the corresponding release. From that release, we can grab the package, and then from the package, we can grab the name. So this should show us, let's get rid of the ID here. So this will show us all of the package names that exist within our resolved manifest, right? Just like you would expect. Now, like I said, we can also tack on vulnerability information. So package has affected by vulnerabilities. Inside of there, we can grab the vulnerability. And then inside of there, let's grab the source ID. So that should give us the CVE identifiers. Give that a run. Looks like we got a lot of data back from this one. Ooh, looked like we got a hit here. So concat stream has a vulnerability. And so we can take that vulnerability, right, and we can reference it. We can show other information about it. Really, the world's your oyster. We're completely open source. So if you're interested in actually seeing what we're capable of, you can look at our database schema. And if you're really interested, you could reach out to us and we'll be happy to tell you about all the different things you can do with this data. But from our perspective, it's really powerful to be able to, on the fly, be able to incorporate any data that we want into a visual representation. So we can do really cool things of, showing your CISO, like how many vulnerabilities do I have in my Go service, right? Answering these questions becomes so trivial when you have all this data modeled. So we're really happy with our schema. We hope that you see value in it. If not, it's nice talking to you. Catch you later.